Have you ever looked at a trig problem and wondered how am I supposed to find the exact value for an angle that's not one of those nice friendly ones on the unit circle? Well, you're in the right place. Today, we're going to crack that very code using these super powerful tools, the sine, sum, and difference formulas. Let's just dive right in.
All right, so let's get right to the heart of the matter. How in the world do you find the exact value of sine 75 degrees? I mean, you know your unit circle, right? You've got 30 degrees, 45, 60, but 75? Yeah, that's not one of the usual stops. So what's the plan? How do we even begin to tackle this?
Okay, before I show you the secret sauce, we have to talk about the number one mistake, the trap that almost everyone falls into when they first see a problem like this. We're going to call it the sine addition trap.
All right, let's break down this trap. I get it. Your first instinct, your brain just wants to treat sine like a number you can distribute, right? It seems so logical. Sine of 30 plus 45 must be sine of 30 plus sine of 45. But nope, that is a huge mistake. You got to remember, sine isn't just a number, it's a function, it's an operation. You can't just distribute it like that. Seriously, this one assumption is the biggest pitfall out there.
So if that's the trap, then what's the truth? How do we actually unlock the answer for these tricky angles? Well, it all comes down to two, honestly, pretty elegant and super powerful formulas. And here's the first key to the kingdom, the sine-sum formula. This is the correct way to expand the sine of two angles being added. So, sine of alpha plus beta equals sine of the first, cosine of the second, plus cosine of the first, sine of the second. That's the pattern.
And its partner in crime is, you guessed it, the sine difference formula. And just look at it, it's almost identical. The whole structure is exactly the same. The only thing that changes is that little sign in the middle. If you're subtracting the angles inside the parentheses, well, then you subtract in the formula. Easy peasy.
Now this is where it really clicks and becomes easy to remember. There's a super simple pattern here. First, notice how the trig functions just alternate. Sine, cosine, cosine, sine. Just repeat that in your head. And the sign in the middle, that's the easy part. It always matches the sign in the parentheses. A plus inside means a plus outside. A minus inside means a minus outside. Simple as that. It's a great little memory trick.
Okay, so theory is one thing, but seeing this in action is where the magic happens, right? Seeing is believing. So let's jump into some step-by-step examples to see how this all comes together.
And here we are, back where we started. Remember our old friend, sine of 75 degrees? Except this time, we've got the right tool for the job. Let's do this.
All right, here's our game plan. It's a simple three-step process. Step 1, decompose. We need to break 75 degrees into two angles we actually know from the unit circle. The obvious choice, 45 plus 30. Step 2, apply the formula. We just plug our angles into that sum formula we just learned. Sine of 45, cos of 30, plus cos of 45, sine of 30. And finally, step 3, substitute and simplify. Now it's just a matter of plugging in those values we all have memorized from the unit circle and doing the math.
And boom, just like that, there's our answer. The exact value for sine of 75 degrees is the square root of 6 plus the square root of 2 all over 4. How cool is that? We literally just found a value that wasn't on our original unit circle map.
All right, you ready for another one? Let's make sure this really sticks. Our new target, sine of 15 degrees. And you can probably guess which formula we're going to need for this one.
And guess what? The process is exactly the same, just with subtraction. First, we break down 15 degrees into two angles we know, like 45 minus 30. Then, we plug those into the sine difference formula. And look, there's that minus sign in the middle, exactly where our memory rules said it would be. From there, it's the same deal. Substitute those unit circle values, do a little bit of algebra, and we've got our answer.
Okay, let's really ramp things up now. What if you don't even know what the angles are? In this problem, we're just given some clues. We know sine of some angle alpha is 3/5 and cosine of another angle beta is 5/13. Our mission? Find the sine of their sum, alpha plus beta. And the craziest part? We can do it without ever finding out what alpha and beta actually are.
So here's the secret. The formula doesn't care about the angles themselves. It just needs their sine and cosine values. So our first step is a little detective work. We use what we're given, like sine alpha is 3/5, and the good old Pythagorean identity to find the other values we need, like cos alpha. We do the same for beta. Once we have all four pieces of the puzzle, sine alpha, cos alpha, sine beta, and cos beta, we just plug them straight into the sum formula and let the numbers do the work.
And check that out. We get a perfect, clean fraction, 63/65. I mean, think about that. We just found the exact sine of the sum of two mystery angles. That really shows you just how powerful these formulas are.
Okay, I know what you might be thinking. This is cool for math class, sure, but when am I ever going to use this? Why does this actually matter? Well, let's talk about a real-world application that you probably use every single day.
Believe it or not, these formulas are at the very core of how sound works. Specifically, they perfectly describe what happens when two different sound waves bump into each other. It's a phenomenon called interference.
So audio engineers use this math, literally the sine-sum formula, to predict how sound waves will add up. If the waves line up just right, they build on each other and you get a louder sound. That's called constructive interference. But if they're out of phase, they can actually cancel each other out, creating total silence. And that is the secret sauce behind your noise-canceling headphones. They're actually generating a new sound wave that's the perfect opposite of the annoying noise around you. The two waves meet, the formula plays out, and you get silence. It's not magic, it's just math. Absolutely incredible, right?
So there you have it. We have totally cracked the code for the sine, sum, and difference formulas. But of course, that's not the whole story. There are also formulas for cosine, and they follow a really similar pattern, but with one key difference that changes everything. Remember our memory trick for sine? The functions alternated and the sign in the middle matched? So what do you think the rule is for cosine? That's your next quest. Happy calculating!